From the velocity time graph above, the acceleration a is given by slope, which is equals to bd over cd, which is equals to v minus u over t, which is our acceleration a, where u and v are the initial and final velocity respectively. Final velocity, making final velocity the subject of the formula, we have that v is equals to u plus at, which is still our equation 1. S, or the slope, is the area of the trapezium OABC. So x, or the slope, is equals to half in bracket OC plus AB close bracket OA, which is equals to half u plus v, or in bracket times t, is equation I. But you know that our final velocity v is equals to initial velocity plus acceleration times time, which is our equation 1, equation II. Substituting II into equation I, we have that the slope, or the distance, is now equal to u plus at all over 2 times t. Then the distance x of the slope is now equal to ut plus half at squared. This is now be our equation 2. For the third equation, the slope is equals to area of a trapezium OABC. S is equals to u plus v over 2 times t by definition, but t is equals to v minus u all over t by making t the subject of the formula. S, we now substitute into we now have u plus v all over t 2 plus u minus v minus u all over a. Since v is equals to u plus at, simplifying, we have v is equals to u plus 2ax. Alternatively, suppose the velocity of an object moving in a straight line with uniform acceleration a increase from a value u to a value v in a time t. Then, from the definition of acceleration, a is equals to v minus u all over t, from which v is equals to u plus at. This will be our equation 1. Suppose an object with a velocity u accelerates with a uniform acceleration a from a time t and attain a velocity v. The distance s traveled by the object in the time t is given by s is equals to average velocity times time t, which is equals to half u plus v times t, but v is equals to u plus at. X is equals to half u plus at times t. Therefore, s is equals to ut plus half at squared, equation 2. Also, t is equals to, in bracket, v minus u all over a from equation 1. Then, s is equals to average velocity times time, which equals to, in bracket, u plus v all over 2 times, in bracket, u minus v all over a, which is now equals to v squared in bracket minus u squared all over 2a. Therefore, making v squared our subject of the formula, we now have v squared, which is our final velocity, is equals to initial velocity squared plus 2 times acceleration times the distance, which is now our equation 3. Example 1. A plank is raised at one end in order to form an inclined plane. A light freely running trolley travels from rest down the plane. The time taken to travel from different points to the lower end of the plank are measured and following results obtained. Distance in cm, time. At 0 distance, the time is 0. At the distance of 50, the time is 14. At the time of 100, the time is 2.0. At the distance of 150, the time is 2.5. At the distance of 225, the time is 3. At the distance of 325, the time is 3.6. Draw a diagram to show that the acceleration is uniform and calculations value. Using this value to calculate the velocity which the trolley would acquire at it traveled 400 cm from the rest along the same inclined plane. Solution. Distance is equals to ut plus half at squared, but initial velocity u is equals to 0. Therefore, distance is equals to half at squared. At the distance of 0, the time is 0. The time squared is 0. At the distance of 50, the time is 1.4, and the time squared is 1.96. At the distance of 100, the time is 2, and the time squared is 4. At the distance of 150, the time is 2.5. The time squared is 6.25. The distance of 225, the time is 3.0. The time squared is 9. At the distance of 325, the time is 3.6. The time squared is 13. Now, plotting our velocity time graph, having an interval of 100, 200, 300 on the distance on our vertical axis, and an interval of 2, 4, 6, 8, 10 on our horizontal axis, we will get a very straight line graph where we are tracing the values. And now we have our slope being traced at a point A. Since graph of distance s versus time squared t is a straight line, it means that the acceleration is uniform. Slope is equals to half at, where half a is equals to ab over ob, which is our 225 over 9. A, making a the subject of the formula, we now have 250 over 9, which will give us 50 cm squared. V squared is equals to u squared plus 2as. V squared is equals to 0 squared plus 2 times 0.5, but u is equals to 0 and s is equals to 400 cm or 4 meters. Therefore, v squared is equals to 0 squared plus 2 times 0.5 times 4, which is equals to 4. Now, v make square going over to the other side will now become the square root of 4, which now give us 2 meters per second. Deceleration a is equals to velocity change over time, which is equals to 25 over 10, which will give us minus 2.5 meters per second squared.